The last year and few months have been almost endlessly cloudy here in the Midlands in the UK. So with astrophotography out of the question, I've been busy working on some powerful new astrophotography processing software called Hera. I've talked about the motivation for this software and its key features in a previous blog post, so I won't go into any detail about that here. I just wanted to very quickly demo the use of this pre-release version of Hera in one unpolished take. It's not a tutorial, but I will just quickly show what it can do in its current iteration. So let's get started. I'm going to fire up Hera here on my desktop, and I'm going to use my latest hard-won 3 hours of data, which is on the Dark Shark Nebula. I've already integrated the best 80% of frames in Deep Sky Stacker, giving me 3 hours overall, and I output the result as a 16-bit TIFF, and this is where the image processing now starts. Here is the Hera interface. The idea is that you add steps in a sequence, and this is the sequence editor down here on the bottom right. So let's add an open image command. So tools, image, open image. And the open image step appears in the sequence editor, and I can now hit the settings button to specify the parameters. So the first parameter is the file address. This is the unprocessed stack from Deep Sky Stacker. So to view the output, I click on the tool, and it appears in the preview window over here, along with its histogram in the bar at the bottom, and a tick appears in the tool in the sequence editor to show that this this step has been computed. So a histogram, as you will probably know, is simply a count of how many pixels there are in the image at each intensity. So it's 0 brightness on the left and full brightness on the right. And for an astro image with lots of dark sky, there's a peak, or in fact here, because there are 3 channels, there are 3 peaks, and these represent the background sky. If you look in the preview here, unless you're an astrophotographer, this probably doesn't look like much to you. It's all very dark and green, and it's dark by intention. It's a 16-bit image, and so with all that ability to resolve detail, I can actually capture the raw data as very dark, keeping the data mostly here on the left-hand side of the histogram without losing any detail, and avoid blowing out the bright stars in the process. And it's green because astro cameras, which operate in extremely low light, are not in general calibrated to a certain white balance. The white balance is something that needs to be fixed in processing. Let me just zoom out, and we can see the whole image. I'll fit on screen. And looking at the image now, I can see that I'd actually like to rotate this image 180 degrees, because when I finish the processing, I want to see the dark shark in its usual orientation. So over here in the open image settings panel, I'm just going to change the rotation to 180 degrees. And as soon as I do that, the tick disappears and the preview disappears, and that's because it needs recomputing. So I can just click on the tool again to recompute it. The next step is to see what we've got. We're going to have a quick and rough look at this. So to do this, I'm going to add an unlinked automatic stretch using the Histogram Transformation tool. An unlinked stretch just means that you stretch each channel separately. Usually you wouldn't want to do this, but it can be effective for a quick look at the data. So I'm going to go to Tools, Histogram, and Histogram Transformation. And now the Histogram Transformation tool appears as the next step. I'll hit Show Settings, and I'm just going to grab this toolbar and pull it over to the left here. And that will just help me to see more on the screen. And I'll zoom more. There we go, the image fits the whole screen, and it will also avoid the video feed overlapping with a key part of the interface. So the default is a linked stretch, which means that we stretch the red, green and blue channels in the same way. So I'm just going to untick that, and I'll hit auto compute and see what we've got. And you can see that because we've stretched all the channels according to the same rules, the same auto stretch parameters, they're all aligned here, but we still can't see very much. Probably I'm just going to change the auto stretch parameters. I find 0.25 is too bright. Let's lower that to 0.1875, and I'm going to pull the shadows in. So the shadows parameter here specifies how many standard deviations away from the median you want to be, and currently I'm 1.25 standard deviations to the left, and I'm just going to change that to something a bit stronger. So we're going to clip it instead of over here, probably we'll clip it over here somewhere. So let's recompute that and see if that helps us to bring out a bit more detail. The dark shark is a very faint target, and most of this data is from a night with a quarter moon. So it is going to be necessary to really do quite a bit more stretching here. I think I'll just add another transformation, and I can leave this one as linked because we've already done one unlinked stretch, and that's probably fine. The auto stretch parameters will probably be okay for that now. There we go. So now we're beginning to see a little bit of detail. You might be able to see this dark cloud of cold dust here. So if I wanted to, I could add another one of those. Just duplicate that, and I could really take it to extremes. Of course, in doing that, we are pulling out an awful lot of noise. And I should say these stretches are temporary, of course. This is not the way you'd actually want to process the image. The process is just to see what we've got so we can figure out the next step. Now, immediately obvious now is that we've got a strong gradient, dark on the left, getting to quite bright on the right, and that will be in part because of the moon, in part because of my neighbour's security light. So we're going to need to do some gradient removal here. So I'm going to go ahead and go to background fitting and gradient removal. This is quite a nice tool, actually, quite powerful, if I can say that myself. The process of the gradient removal tool is to add samples in locations that represent the background sky, and then the software will fill in the gaps between the samples and to the edges to calculate the background sky brightness and color variation over the image and subtract that from the original image. There are various tools out there to do that, and some of them have some premium prices, and I've no idea how they work. Maybe they use 2D polynomial fitting with algebraic surfaces, which was my first idea, but actually my technique in this software is to solve the 2D Poisson equation. The Poisson equation describes many physical processes, including heat transfer and diffusion. So in doing that, the software fits results to it fits a surface, if you like, to the provided sample points by using the finite element method. Actually, it turns out the Poisson's equation is kind of irrelevant for the spaces between the interior points, as the variation between sample points is really just described by the interpolating functions called shape functions. But the technique comes into its own when extrapolating to the boundaries of the image, as the software can figure out pretty well what happens between the sample points and the image boundaries, even if there are no samples near the boundaries. So anyway, what I'm going to do now is just go around the image adding samples. So I'm going to hit the Add Selected button here, and I'm looking for parts of the image which will, I think, represent the background. So I'm going to add a sample point there. If I click on it, you can see a preview. That looks fine. Let's put one in. Let's put one in here. I just need a few points to capture the variation of the background sky brightness across the image. It's quite a noisy image. I don't have enough data for this really, so I'm increasing the sample size up to 31 pixels across, and the reason for that is just to get a better average. The point of the preview is to check if you've accidentally picked up any stars, and sometimes I do, so I can just nudge it a little bit and make sure I haven't picked up any. So over here in the top right corner, I want to steer well away from the nebula itself so I don't accidentally subtract any of the dark shark. Let's go for one in there. And I'm probably getting close to enough now. I don't need to go overboard because the software's pretty good at filling in the gaps. Maybe I'll put one in. I'm going to risk it and go for one in this gap here because I reckon that is a bit of dark sky in contrast to the nebula, even though it's pretty nearby. Let's just shift that a little bit, and maybe I'll put one in here. I guess I've probably got enough, but there's no harm in doing this. So the next step, I'm just going to extract the background and see what it looks like, and see if that looks about right. Oh, there's something going on here in that top corner. Let's just have another look at that. Oh, I think I've accidentally added a point in there. Let's just remove that one. I don't want that because that's clearly not on background. And try again. Yeah, that's better. So I'm going to go ahead and set that to subtract. And these histogram transformation steps are just there for quick, rough viewing, and because the gradient represents an unwanted signal, I really just need to subtract that as soon as possible. So the first thing I do after opening the image is subtract the background. So let's compute that. Now we can begin the next step, which is color calibration. So color calibration happens in two steps. First, I need to neutralize the background in an area of more or less empty sky. So that will mean that the mean value of the background is equal in all three colors, giving a gray color. And the second step is to calibrate the color by setting the color of all the stars to be white or a bright gray on average. So first, in color calibration, I'll do the background neutralization. I just want to decide where to place my background. Yeah, so I think the best bit of background here is probably here in the bottom left. So that's what I'm going to do. I'll move my histogram transformation back, and let's go for. I should preview it so you can see what I'm doing, and I can move this about. I'm just going to shove that here in the bottom left, and let's show the mask. So at the minute, when I tick this mask button, anything that's green is excluded from the average, and clearly that's not going to work. So I can move this slider here until I've blocked out the stars, which I want to exclude from my average, but haven't blocked out the sky. So that seems about right. Let's try 0.13, yeah, so 0.14 I include a few more stars, 0.12 is too many, so let's put that at 0.13, and each of these green blobs is a star that's going to be blocked out from the average. So that's the background neutralization done, I think. And you can see that in the histogram at the bottom here, now all of the channels, I've got red, green and blue, they're all aligned, and this is the background peak we're seeing here, and given that I've just neutralized the background to grey, it's no surprise that they're now all aligned. By the way, this is just viewing the data I'm viewing it in 8-bit buckets. I could view it in 16-bit if I wanted to, and it just takes a little bit longer. I mean, it's still pretty fast, but for the most part, it's fine to leave it in 8-bit. All of the processing is in 32-bit, so changing this doesn't affect the bit level of the processing at all. So I've sorted out the background level. The next step is the white balance. So I can do that using the color calibration tool. And again, I'm going to move that up here to just after background neutralization and open the settings. So color calibration has two main inputs. One is the white reference and one is the background reference. The background reference is just the same as in the background neutralization tool. That's going to identify which pixels represent the background. And actually in this tool, it's going to hold the intensity in each channel of those background pixels fixed, and then it's going to stretch out the other pixels in each channel to give the white value. So we're going to measure the white value by taking an average of all the stars in the image. So let's just preview, and actually this white reference box is very effective. It works by using wavelet transforms, and it's very good at identifying the stars, and it blocks out anything that's nearly pure white to avoid that showing off the calculation of the white level. So really I don't need to do anything here with the white reference at all. I can leave that. For the background reference, I'm just going to set the bottom left corner. So let's move that box down here and hit show mask. And what did we have before? Let's grab the slider. So I think, yeah. So I think that's everything that needs to be done in the color calibration panel. So let's compute that and see what it looks like. Now we can sort out these histogram transformations properly. So the color sorted, I therefore need to do links transformations. That's just because I need the red, green and blue channels to be treated in exactly the same way now, otherwise the color will be incorrect. And auto compute, let's see what we've got. Okay, so as expected, the colors look okay, and you can kind of see something's going on here, but we need to do another stretch just to see what that is. So I'm going to set the mean value to a little bit darker. It's that 3/16, I think, and auto stretch that. Let's calculate these values, and you can see it's the we've got input to output in the preview of the transformation here, and we are where you've got a steep gradient, you're stretching out values more. When you've got a shallow gradient, you're bunching them together. So the steep gradient here is across the background peak as we want, and there we go. We're beginning to see some more detail. And I haven't done any denoising. I haven't added any denoising tools to Hera yet, but I will be soon. I've got two quite powerful tools actually, in development, and they'll be added soon, but they're not ready yet. So I mean, what I could do, I could overstretch it and really blow out the noise, and that would make it even more difficult to remove. But actually what I'm going to do is I will export this version and pull it into Photoshop and finish the image there. But that doesn't stop us taking a look. So clearly the noise has really gone rather extreme here, and but we can certainly see the dark shark. I've missed a key step actually. So you can see that we've got we've got some kind of artifact around the edge here, and that's going to be due to the stacking. So I gathered the data with dithering, so that means that the telescope moves, or the image on the sensor moves a number of pixels in between every frame, and that's by intention to reduce the noise. So I'm just going to crop that out. This kind of thing is unavoidable when you're stacking, because the images never align perfectly because by intention, because of the moving image on the sensor between frames. So I'm just going to hit the settings on that and set the aspect ratio to 2/3, which matches the sensor, and I'm going to pull that in. That more or less cuts off the artifacts, and yeah, there you go. So I'll pull that down here to just after the gradient removal. This is the step that I want to export, and if I'd had some denoising tools built into Hera by this point, then I would have continued the processing. You can see the dark shark here, but that's not what I'm going to be working with. So I'm going to save this file. So what I'm doing is saving a sequence file. Let me show you what I mean by a sequence file. This is just a text file, and it's tiny. See what that is? It's 2 kilobytes, and the whole idea of this is that I don't want to be saving enormous intermediate steps, and all I want to do is to open the sequence file and recompute it, and if you can do that fairly quickly, then that's no hassle at all. So that's the sequence file, so I can close that and reopen it if I want to, but actually after I finish the processing I do want to export the image, and I want to export it as a 16-bit TIFF, like that. And now I'm going to pull that into Photoshop. So there it is, pulled into Photoshop. It's not quite the same image because it will be fractionally different because I processed it, of course, ever so slightly differently in the past. And I'm not going to go through processing in Photoshop in any great detail because that's not what this video is about. But this is the first layer, and then I've used some Topaz Denoise AI. I don't really like using Topaz, but for a target like this, with only 3 hours of data and a moon, sometimes you just need to do what you can. And with all the cloud, obviously I prefer more data, but I can't do much about that. So anyway, I've used Topaz, I've protected the stars from the denoising, I've done a little bit of star minimization, then I've used some camera raw filter. So the camera raw filter in this step is using some additional denoising. I've turned on some chromatic noise reduction because of a little bit of green going on down here. So I could have used something like an SCNR algorithm, but I haven't got that in Hera yet. But it's easy to do in camera raw filter. There we go. I've used an astronomy actions tool called Less Crunchy, More Fuzzy. If I zoom in, you can see the very subtle effect on the stars, off and then on, very subtle. And then a little bit more camera raw filter, and what did I do in that one? I can barely see the difference. Okay, a little bit more degreening. I'm using this tool, I'm turning the saturation down to remove the chromatic noise from the green. A little bit of curve stretching, a little bit of contrast, a luminosity layer, and then finally a star minimization, and that's the final image. Anyway, that's all I've got for you. Thanks for watching. If you're interested in keeping up to date on the Hera projects, or on possibly using the software in the future, or doing some beta testing for me at some point, then please do leave a message.